This one's going to be really neat. I'm going to expedite this process. And when we get this, I'll go ahead and tell you what the shape looks like, although I hate to give it away. It's going to be a limacon. Okay, do you have to know these by heart? No. Do you need to be familiar with the name of them? Vaguely, yes. Let's start with the obvious. Rose curves, they look kind of like flowers. They can have multiple petals. Don't panic about remembering all the formulas. Do not panic about that, all right? Not a huge deal. Circles, you know what those are. You actually just graphed one. Limniscate, I made that up. I assume that's the way it's pronounced. It might be limniscate or some weird thing where you just like spit in the middle of the word. Limniscate, I don't know. Anyway, however it's pronounced, and I should have found out before I started recording, you're going to get one of these kind of loopy-de-doople things. There you go. But we're going to graph this one up here, and it's going to be a limacon, and it's going to be of this form. It's going to be a cosine one, obviously. So a plus or minus some constant b, cosine of theta, 2 plus 4 cosine theta. All right, let's use a calculator at first on this, because I would love to just work through all this and be like 2 plus 4 times cosine of 0. Crank it out. 2 plus 4 times cosine of pi over 6. Let's not. Y equals 2 plus 4 cosine of theta. And even though I could press graph right now and get a thing and just be done with it, no, we need the sequence of this one for sure. I have seen a lot of free response questions or questions that ask for the area of a limacon, and you need to know the sequence of how this thing graphs. So let's go to the table. I'm going to delete some of the random numbers that are in here that have nothing to do with this problem, and I'm going to plug in 0, and when I do, I get 6. So 6 comma 0, this is my r, this is my theta, and so the coordinate kind of reads backwards. So theta and then r really becomes r theta. So I'm really going to even just leave this one blank. I'm going to fill in that final column, and we'll fill it in red because this one's fun and exciting. So this one's going to be 6 comma 0. Then we're going to plug in pi over 6, and we're going to get 5.464 comma pi over 6. And for consistency with decimals, I'm going to use 3 decimal places. But again, realistically, you're not going to be like, oh, is that 5.464 or 5.463? We're estimating it. All right, let's plug in pi over 3, and we're going to get 4. That's convenient. 4 comma pi over 3. Let's plug in pi over 2, and we're going to get 2. So 2 pi over 2. That was also convenient. 2 pi over 3 is going to give me 0. 2 pi over 3. And then 5 pi over 6 is going to give me negative 1.464, comma 5 pi over 6, and then plug in a pi, which we could do in our head. Let's do that one in our head. If you plugged in a pi right here, cosine of pi would be negative 1. That would be 4 times negative 1 would be negative 4. 2 minus 4 would give me negative 2. There. That one was fun. Okay, we're only halfway through here. Let's go ahead and start plotting what we have, and we'll use purple. 6, 0. Okay, rectangular, polar, same thing in this case. 5.5 pi over 6. 5.5 pi over 6. 4, 1, 2, 3, 4 pi over 3. Exactly 4. 2, 1, 2 pi over 2. 0, so it doesn't matter how far we swing around. There we go, 0. And then negative, whoa, fun times. All right, negative 1.5-ish. And then positive 5 pi over 6. You might be pointing there. It's not there. We're going to move in a positive direction, the equivalent of this. Okay, we're not going to here. We're going this angle measurement. So negative 1.5, and then that equivalent, which actually takes us to 11 pi over 6. So about right there. And then negative 2 comma pi, which would put us on the positive side of the x-axis. Okay, we have drawn half of it so far, and I wanted to stop here so we could sort of get a picture of what's happening. This is one of those that it's good to sort of trace the process, because you will need these skills later. I know I keep saying that, but later someone's going to walk up to you and say, hey, will you find the area of this little piece right here, and you're going to be stuck trying to think, okay, now where did this thing start? Where does it end? What's our theta measurements that got us here? This process is helping to gain an understanding of that. Okay, I have, off camera, an answer key that has the rest of these filled in. So for the sake of time and the fact that you could just type this yourself, let's just very quickly go through this. And just to be kind of clear with this, they are going to have the same R values symmetrically moving up this way. So the R values are going to be the same. So like that's going to be the same R value, same R value, same R value. So there we go. It's just, now you know. So negative 1.464 comma 7 pi over 6. 0, 4 pi over 3. And 2, 3 pi over 2. And 4, 5 pi over 3. And I'd love to discuss why they are symmetric in this way. It has to do with the shape of the cosine graph. And I'm trying to explain it while I'm talking, which is very difficult to do. 2 pi. There we go, 6 and 2 pi. All right, let's plot these as well. And yeah, we'll do it in blue so it stands out just a little bit. So we've plotted up to here. Let's start with this one. Negative 1.5, negative 1.5, and then 7 pi over 6. 7 pi over 6 would take us here if we were moving in a positive direction. Well, we are moving in a positive direction, but it would take us this far, so let's go that far. So 1.5, 7 pi over 6. There we go. 0. Okay, well, that takes me back to the origin. Good to know. Because it loops over itself? Yeah, that's why we need these skills. And then 2, comma 3 pi over 2. 4, 5 pi over 3. 4, and then 5 pi over 3. And then 5.5. And then 11 pi over 6. Takes me back around to here. And then 6, 2 pi. And that is a limicon. Isn't that neat? I like that.